Good morning. I am Senthil Madasamy. Today I am going to talk about basics of neural network. The subject of neural network has assumed to a great extent over the past few years, and especially with the advent of very high performance computing. The subject has assumed a tremendous significance in recent years. Now we are going to know about the basics of neural network. So we will be defining what neural network means, as a name implies. Actually, the term neural network derives its origin from human brain and human nervous system, which consists of massively large parallel interconnection of large number of neurons. It may be connected more neurons also, and that achieves different tasks, different perceptual tasks, recognition tasks, etc. in an amazingly a small amount of time, even as compared to today very high performance computers. That is going to be the topic of today, and specifically we are going to address the neural network. Now we know that about human brain is highly complex and non-linear and parallel computers. Structural conscious neurons, our human brain has got typically billions of nerves with the trillions of such interconnection existing. Now, let us, understand something which we can give as an example. Let's say familiar task of recognition. Whenever we meet a person who is known to us, we can recognize that what is the name of the person, because he must be friend of ours, he must be some known person, and we will be able to tell that who he is whenever he met him, and how is that we are going to do it. We are going to perform a task of recognition. Now we may be knowing of thousands of people around, and I mean that what you have to do is immediately instantly recognize that person by us. That I mean he is somebody who I had met 5 years ago, and his name in church, and such he works in church and such a place, or I had met him in connection with these works. We can immediately have this recognized task. This recognition, now supposing instead of ourselves doing it, I ask the computer to do this work, to do this task. But here, how much of time would you think that a conventional computer is going to take? Okay, it is not going to be any key computation for a computer, because the firstly we know the person, but computer doesn't know the person. First, we have the computer for recognition. We need to store the 1,000 people photos, but we need a database. But after the recognition take place by matching with 1,000 photos, the resembled matched photo will be recognized. This by using the computer, the recognition taken place by using some algorithm. But our brain has got typically billions of nerve cells with trillions of such interconnection existing. Okay, for the computer we must have the database. Okay, in computer we have the more number of ICs will be fixed in this. IC take the 10 power minus 9 seconds, but in processing of human is in 10 power minus 3 seconds only. But we have the massively parallel network neurons, 10 billion neurons, 60 trillion interconnections in our human brain. But we can't do in really. Okay. Now see the structure of the human. Now rather than drawing a human brain, we will be considering a typical nerve cells. Okay, typical nerve cell, which we refer to as pyramidal cell, and that should look something like this. Okay, something like this. But let us say that now we draw this one. Okay, this cell body, this is cell body, and with that we now connect this axon. These axons are basically acting like a transmission lines, the lines that can carry the electrical signals. And in terms of it is electrical characteristics, one can say that it is having the high degree of electrical resistance and offers a large capacitance. The axons, they act as a transmission lines for carrying the electrical signals, and they end up with. So here you can see that there is some tree-like structures, and all this ultimately end up in synaptic terminal. Synaptic terminal. It's a snaps. Okay, synaptic terminal. But it is a response zone. Okay, it will be connected to the another neurons through axon, and also it is a synaptic terminal. It is coming from another cell, another neuron. Okay, but here we have mentioned another term, dendrite. But here have the two types, apical and basal dendrite. But dendrite is a receptive zone. We are getting the input from other neurons. There is a receptive zone. There is a dendrite. It's a dendrite we are mentioning. But when compared to the axon, the length of the line will be less in dendrite when compared to axon. But in center of the body, we indicating the nucleus. But here next it is a natural neural network, but we are going to use the artificial neural network in our computer. Okay, as like this topology. But here the inputs are given x1, x2, x3 like that. This is a input layer and the hidden layer. The processing will be done in the hidden layer, and then the passing the response to the output layer by using some activation functions. Okay, for learning functions will be given. The output will be got. In next coming sessions we will know about it. Thank you.